Okay, so let's do another practice problem. The next one's going to be hydrogen peroxide. So hydrogen peroxide is H2O2. Go ahead and pause the video, see if you can draw out a possible structure for hydrogen peroxide. Okay, so you may have gotten one of these two possibilities. Let's just call them possibilities A and possibilities B. So one of these structures is correct and the other one is incorrect. So the way we'll go about trying to figure out which is right and which is wrong is to go ahead and do formal charge calculations for each one of these and also see if we're violating any rules. So go ahead and pause the video and see if you can do formal charge calculations for both example A and example B, and see if you can shoot down one of these structures. Tell me why one of these structures is incorrect. Okay, so now if we do the formal charge calculations for the oxygen on molecule A, we'll find that this oxygen, just like always, it has a valence of 6, and so then we're going to subtract 2 from that for the two covalent bonds, and then subtract the total number of electrons in the lone pair configuration, so that's 2, 4. So we'll do 6 minus 2 minus 4, and that's going to equal 0. And so for this hydrogen, we would do the formal charge calculation for this guy, just saying the valence would be 1, and then we'll subtract the total number of bonds, which is 1, and then we have no lone pairs, so this is going to be 0. So 1 minus 1 should be 0. And everything seems to work out for A. If we compare and contrast to B then, there are a couple of things that are wrong with molecule B. The first off is the total charge calculation for each one of these. If we went through the charge calculations, we'd find that the hydrogen is negative and the oxygen is negative. So if we went through, the oxygen has 6 as its valence minus 1 covalent bond, minus 2, 4, 6 electrons that are in the lone pair configuration. So we're going to get a negative 1 charge for that oxygen right there. This oxygen is still going to be neutral. So then we could do the formal charge calculation for this hydrogen, and it would be 1, again, minus 2 covalent bonds, and then we have no lone pairs. And so this is going to be negative 1 as well. So there are a couple of things that are wrong here. The first off is that we're breaking two very, very fundamental rules. The first is the duet rule. So this would be breaking the duet rule for this hydrogen because this hydrogen has a total of 2, 4 electrons that are surrounding it. So we're automatically breaking the duet rule. So this guy is no good. That's one reason this molecule is no good. The other reason is, although having a negative charge on an oxygen isn't necessarily a bad thing, if you can compare and contrast the formal charge for this H2O2, it's net neutral, versus if you compare the neutrality or the net charge on this molecule, we have a net charge of negative 2. So we have a disconnect between the charge for the molecule that we want to draw and the charge for the molecule that we actually drew. So at the end of the day, molecule A looks great and gets a happy face, and molecule B is not so good, and he gets a frowning face.